Hello students, look at the next example of LPP containing unbounded feasible region. The question is maximize z is equal to minus x plus 2y subject to the constraints x greater than or equal to 3, x plus y greater than or equal to 5, x plus 2y greater than or equal to 6 and y greater than or equal to 0. Now remember the method. We solve these inequalities one by one, and for each of the inequality we follow two steps. The first step is to find the points on the line of the inequality, and the second step is to find the solution region of the inequality. Now let us solve this example. The first inequality is x greater than or equal to 3. First step, the equation of the line is x is equal to 3. I have replaced the inequality sign by equality. Let us call this as equation 1. Now observe here. This equation is saying that the value of x is fixed to 3 and it is independent of y. Whatever the value of y may be, the value of x remains same, equal to 3. If y is 0, x will be 3 itself. If y is 1, again x will be 3. Look at the graph. If y is 0, x will be 3. The value of x is 3. If y is 1, again x remains same. If y is 2, then also it will not change, x will be 3. If y is the negative, that is minus 1, then also the value of x is 3. Now I will draw the line passing through these points. Also, in the inequality we have equality sign. So I draw a solid line passing through these points. This is the line and its equation is x is equal to 3. Observe here, this line is parallel to y-axis and it is at a distance of 1, 2, 3 units from the y-axis towards the positive direction of x-axis. So remember that if the given equation is of the form x is equal to a, then this will be always a line parallel to the y-axis at a distance of a units from the y-axis. If a is positive, then the line will lie towards the positive direction of x-axis. If a is negative, then you have to draw the line towards negative direction of x-axis. So directly we can write x is equal to 3 is the line parallel to the y-axis at a distance of 3 units from the y-axis towards the positive direction of x-axis. Or you can also say that it is the line parallel to y-axis at a distance of 3 units to the right side of the y-axis. If you have not understood this concept, then you can also use the points to draw the line. Remember here x is fixed to 3. You can take different values for y. If y is 0, x is 3. If y is 1, again x will be 3. Now draw the line passing through the points, through these points, and you can write that the line passes through the points 3, 0 and 3, 1. Next, to find the solution region, the inequality is x greater than or equal to 3. Then clearly in the graph you can say the values x greater than or equal to 3 lies to the right side of this line. All these values satisfy the condition x greater than or equal to 3. So directly you can shade this region and you can conclude that the solution region lies to the right side or towards the positive direction or away from the origin. Or you can also verify this by substituting the origin in the inequality as we did in other inequalities. Put x is equal to 0 and y is equal to 0 in the inequality x greater than or equal to 3. We get, put x as 0 here, the inequality will become 0 greater than or equal to 3, which is false. The origin doesn't satisfy the inequality, therefore the solution region lies away from the origin. So in the graph, this is the region lying away from the origin, so this will be the solution region for the inequality. This is about first inequality. The second inequality is x plus y greater than or equal to 5. For this inequality, the equation of the line is x plus y is equal to 5. The first step is to find the points. Substitute x as 0 in this equation, we get y is equal to 5. Put y as 0 and on solving we get x is equal to 5. We have called this as equation 2. The line passes through the points 0, 5 and 5, 0. The second step is to find the solution region. Substitute the origin in the inequality. We get 0 greater than or equal to 5, which is also false. Then the solution region lies away from the origin. This is about second inequality. Now the third inequality is x plus 2y greater than or equal to 6. For this inequality, the first step is the equation of the line is x plus 2y is equal to 6. Call this as equation 3. And put x as 0. On solving, we get y is equal to 3. Similarly, put y as 0 in this equation. On solving, we get x is equal to 6. Therefore, the line passes through the points 0, 3 and 6, 0. Now the second step is to find the solution region. Substitute the origin in the inequality. We get 0 greater than or equal to 6, which is also false. Therefore, the solution region lies away from the origin. And the last inequality is y greater than or equal to 0. For this, the equation will be y is equal to 0. Again, this equation says that the value of y is fixed to 0 and is independent of x. So x can take any value. Y is always 0. Look at the graph. If x is 0, then by the equation y will be 0. If x is 1, it doesn't affect the value of y, so y will remain same 0. If x is 2, again y will be 0 itself. If x is minus 1, y will be again 0. If I draw a line passing through these points, then this line coincides on the x-axis. So, y is equal to 0 is the equation of x-axis itself. Also remember that we already know every point on the x-axis will have its y coordinate 0. So directly we write y is equal to 0 is the equation of x-axis. Also note that if the equation is in the form y is equal to b, then this will be a line parallel to x-axis at a distance of b units from the x-axis. If the value of b is positive, then the line will lie above the x-axis towards positive direction of y. If b is negative, then the line lies towards the negative y-axis. Now, to find the solution region, look at the inequality. Y is greater than or equal to 0. That is, y is non-negative. Non-negative means equal to 0 or greater than 0. It lies above the x-axis in the first and second quadrant. So directly you can shade this region. So I have written the solution region lies above the x-axis. I had discussed all the inequalities. So now I have to draw the graph. I have already drawn the graph of first inequality. Now for the second inequality, the points on the line are 0, 5 and 5, 0. x0, y is 5, 0, 5 and 5, 0. The inequality contains the equality sign also. So I draw a solid line passing through these points. I'll draw the line. This is the line. Now I'll rub this and write the equation of this line. X plus y is equal to 5. The solution region for this inequality lies away from the origin. So this is the region lying away from the origin. Now the second inequality, the points on the second inequality are 0, 3 and 6, 0. 0, 3 and 6, 0. The inequality contains the equality sign also. So I draw a solid line passing through these points. I have drawn the line and written its equation. Now the solution region of this inequality lies away from the origin. This is the region lying away from the origin. And the last inequality is y greater than or equal to 0. For that I have already drawn in the graph. Now we have to discuss the feasible region. For the first inequality, the solution region lies to the right side of the line. For the second inequality, the solution region lies away from the origin. Now the common region for these two inequalities is to the right side of the line and above the second line. For the third inequality, the solution region lies away from the origin. So common for these three is to the right side of this line and above both of the lines. And for last inequality, y greater than or equal to 0 means above the x-axis. So the feasible region or common solution region for all the inequalities is above the x-axis, to the right side of the line x equal to 3 and above these two lines. So this is the feasible region. I'll shade the feasible region and rub the remaining shaded region. This shaded region is the feasible region, and observe here, this is unbounded. It is not closed. So we write the shaded region is the feasible region and the feasible region is unbounded. Now the corner points of this feasible region are, so in this region, shaded region, these are the corner points. I can name them as A, B and C. A is the point of intersection of these two lines. So the coordinates of this point can be determined by solving these two equations, or also by the graph. It is very clear that the coordinate of this A are 3, 2. X coordinate is 3 and y coordinate is 2. That is 3, 2. Or you can also determine this by solving the equations. I'll solve the equations to find the coordinates of A. X equal to 3 is the first equation and this is the second equation. Let us solve equation 1 and equation 2. Equation 1 is x equal to 3. Equation 2 is x plus y equal to 5. The coefficient of x are equal in both of the equations. So if I subtract equation 1 from equation 2, then I can cancel x terms and I'll get the value of y. Or also you can substitute the value of x as 3 from equation 1 in equation 2. I have substituted x equal to 3 in equation 2. 3 plus y is equal to 5. On solving we get y is equal to 2. Therefore, the coordinates of point A are x is equal to 3 is already given. and y is equal to 2. So it is 3, 2. Write the coordinates in the graph 3, 2. B is the point of intersection of these two lines. So the coordinates of B are determined on solving these two equations, equation 2 and equation 3. Equation 2 is x plus y equal to 5. Equation 3 is x plus 2y is equal to 6. The coefficients of x are equal in both of the equations. So I'll subtract equation 2 from equation 3 so that we can cancel x terms and we can determine the value of y. Equation 3 minus equation 2. X get cancelled. 2y minus y is y. 6 minus 5 is 1. Now substitute this value of y as 1 in equation 2. X as it is plus 1 is equal to 5. We get x is equal to 4. Therefore, the point B is x comma y, that is 4 comma 1. I'll write these coordinates in the graph. Point B is 4 comma 1. Now, this is the point C and its coordinates are 6 comma 0. Now, what is the next step? We write the corner points of the feasible region are A of 3, 2, B of 4, 1 and C of 6, 0. Then the next step is to evaluate the value of Z at these corner points. So draw the table. In the first column write the corner points and in the second column write the values of Z. For the first point 3, 2, substitute x as 3 and y as 2 in this equation. We get minus 3 plus 2 into 2. Minus 3 plus 4 is plus 1. Similarly, put x as 4 and y as 1. We get minus 4 plus 2 is minus 2. For the third point, we get z as minus 6. Now the question is to find the maximum value of z. Here, the greatest value is 1. But the feasible region is unbounded. So, this 1 may or may not be the maximum value. So, we write as the feasible region is unbounded, z is equal to 1 may or may not be the maximum value. And remember that in this case, we have to solve one more inequality. That is, we have to check whether there exists any point in the feasible region for which z can take the value greater than this greatest value, that is 1. Z greater than 1, what is z? Minus x plus 2y. Minus x plus 2y greater than 1. We have to solve this inequality. So, for this, we draw the graph of the inequality or we write the inequality minus x plus 2y greater than 1. Now again for this inequality we follow two steps. The first step is equation of the line is minus x plus 2y is equal to 1. To find the points, substitute x as 0 in the equation. If x is 0, the equation becomes 2y is equal to 1, y is equal to 1 by 2. Put y as 0, we get minus x plus 0 is equal to 1, minus x is equal to 1, that is x is equal to minus 1. Therefore, the line passes through the points 0, 1 by 2 and minus 1, 0. Next, to find the solution region, substitute the origin. In this inequality, we get 0 greater than 1, which is false. Then the solution region lies away from the origin. Let us plot the graph for this. Points on the line are 0, 1 by 2 and minus 1, 0. X 0, y 1 by 2. Point 5 is here. Another point, minus 1, 0. X is minus 1. X is minus 1 and y is 0. And the inequality is strict inequality. I draw a dotted line passing through these points. I'll draw the line. This is the line. Now the solution region lies away from the origin. Origin lies below the line. The solution region lies above the line. Now observe here, the solution region of this inequality have some points common with the feasible region. This means that there exist points in the feasible region for which the inequality satisfies. The inequality satisfies means z greater than 1 satisfies. That is, there exist points in the feasible region for which the value of z can be greater than 1 also. So, 1 is not the maximum value of z. And we conclude that the feasible region has points in common with the inequality. Therefore, z equal to 1 is not the maximum value, and hence z has no maximum value. This completes the solution. Next example is maximize z is equal to x plus y subject to these constraints. We solve the inequalities one by one. So the first inequality is x minus y less than or equal to minus 1. First step, the equation of the line is x minus y is equal to minus 1. Call this as equation 1. Now to find the points on this line, substitute x as 0. Then the equation will become minus y is equal to minus 1. Minus minus get cancel, then y is equal to 1. Now put y as 0 in equation 1. We get x is equal to minus 1. Therefore, the line passes through the points 0, 1 and minus 1, 0. Now the second step is to find the solution region of the inequality. For that, substitute the origin in this inequality. We get 0 less than or equal to minus 1, which is false. Then the origin is not included in the solution region, and the solution region lies away from the origin. Now the second inequality is minus x plus y less than or equal to 0. First step, the equation of the line is minus x plus y is equal to 0. Call this as equation 2. To find the points, put x as 0 in this equation. We get y is equal to 0. Now remember that the constant in this equation is 0. Then the line of this equation always passes through the origin. So origin is one of the point on the line. Then to find another point, I cannot substitute y as 0 in this equation, because for y is equal to 0, already we have the value of x as 0. Then to find another point on this line, substitute any other value for either x or y in this equation. I'll substitute x as 1 in this equation. Then we get minus 1 plus y is equal to 0. Then y will be equal to plus 1. So the value of y is 1. Therefore, the line passes through the points 0, 0 and 1, 1. Now, we have to find the solution region of this inequality. But before that, let us draw the line of this inequality in the graph. The points are 0, 0 and 1, 1. 0, 0 and 1, 1. The inequality contains equality sign also. So I draw a solid line passing through these points. This is the line and I have written its equation. Now observe here, the line is passing through the origin and dividing the plane into two regions. One of these two regions will be the solution region. Observe here, these regions cannot be differentiated as either towards the origin or away from the origin. They are differentiated as either to the left side of the line or to the right side of the line. So, we do not substitute the origin in the inequality to find the solution region. We substitute any point of this plane from any of the two regions in the inequality. Let us choose the point 3, 1. Substitute this point in the inequality. If it satisfies the inequality, then the region lying towards this point or the region including this point will be the solution region. If this point doesn't satisfy the inequality, then the region which is not including this point will be the solution region. Let us substitute the point 3, 1 in the inequality. I'll substitute x is equal to 3 and y is equal to 1. In this inequality, we get minus 3 plus 1 is less than or equal to 0. Minus 2 is less than or equal to 0, which is true. Therefore, the region containing this point and this region lies to the right side of the line, or you can say the region lying towards the positive direction of x-axis is the solution region. So, I have written the solution region lies towards the positive direction of x-axis, and we can shade this region. This region is the solution region. This is about second inequality. Now the next inequality is x, y greater than or equal to 0. These are non-negative constraints, and this says that the feasible region lies in the first quadrant. Since x, y greater than or equal to 0, the feasible region lies in the first quadrant. I had discussed all the inequalities. Now let us draw the graph of the first inequality. The points on the line are 0, 1 and minus 1, 0. X 0 and y is 1, 0, 1. Another point minus 1, 0. The inequality contains the equality sign also, so I draw a solid line passing through these points. This is the line and written its equation. The solution region for this inequality lies away from the origin. So, the origin lies below the line, then the solution region lies above the line, away from the origin. And the non-negative constraint says that the feasible region lies in the first quadrant. So, we restrict the shaded region only in the first quadrant and rub the region shaded in other quadrants. I have shaded the solution regions in the first quadrant and rubbed the region shaded in the other quadrants. Now observe here, this region is the solution region for the first inequality and it doesn't satisfy the second one. Similarly, this region is the solution region for the second inequality and it doesn't satisfy the first inequality. Then, these two inequalities have no common solution region and hence there is no feasible region for these inequalities. If there is no feasible region, then the objective function z cannot have its maximum or minimum value. So, we conclude that from the graph it is clear that there is no common region and hence there is no feasible region. If there is no feasible region, then z has no maximum value. This completes the solution.